I'll be talking about acceleration in this video lesson. And the word acceleration simply means, or to accelerate means to increase the speed of a body. Although people commonly say acceleration, increase your speed, speed up. To decelerate means to slow down. But in physics, how do we view acceleration? Because it's a physical quantity, a vector quantity that is having both magnitude and direction. Acceleration is defined as the rate of change of the velocity of a body, the time rate of change. Velocity change over time taken is a vector quantity having both magnitude and direction. So we can see that in symbols, you can write it as delta v, which is the velocity change over time taken for the change. So that velocity change has the unit meter per second. ms minus 1, the time is second. So we can quickly derive the unit of acceleration. Meter per second, that simply gives meter per second squared or meter per square second. Or ms raised to power minus 2, that gives the unit SI unit of acceleration. Now, in differentiation or in calculus, acceleration is also seen as the derivative, the first derivative of the velocity of a body with respect to time, the v over dt, or in terms of position or displacement, acceleration is given as the second derivative, the squared x over dt squared. Don't bother yourself about this. For those of you just learning this for the first time, this is for those that have done some a bit of other mathematics. So in calculus, this acceleration has been defined as either this derivative or the second derivative of the displacement of a body with respect to this time taken. Okay, so we have seen that as acceleration. Now, if the change in velocity is zero, that is, if there's no change in velocity, that is delta v is zero, it means the body does not accelerate. Here, the final velocity, we use the symbol v for final velocity, and we use symbol u for the initial velocity. The initial velocity can be taken at an earlier time. Let's say some t is equal to 5 seconds. We can register the initial velocity at this time and then wait for maybe, let's say, 10 seconds later, you know, or 15 seconds later, register the final velocity. So if maybe 55 seconds earlier, the velocity was 10, that is the initial, and let's say after 15 seconds, the final velocity remains 10 meters per second. This shows us that the final equals the initial, and the change, which is the difference between the final and the initial velocity, is zero. That is 10 minus 10 gives us zero, meaning that the velocity of the body did not change, and therefore the acceleration of the body is zero. So when delta v is zero, if a body's velocity does not change, it means the body is not accelerating. As long as it is moving along a straight line, we are looking at motion of a body along a straight line. The body is moving with a constant velocity. At this point A, the velocity of the body, let's say, is 10. At point B, is still 10, maybe a few seconds later. A few seconds later, the body's velocity remains 10. We can see here, since the speed is constant along a straight line, no change in direction, we can see that the velocity or the acceleration of this body is zero. So a body only accelerates when the velocity changes. So let's look at case 2. In this case 2, the change in velocity of the body is positive. When there's a positive change in velocity, it means here that the acceleration of the body will also be positive. So positive acceleration or positive change in velocity is simply acceleration. And for delta v to be positive, it means the final velocity must be greater than the initial velocity, because velocity change is the difference between the final and the initial velocity. So if the final velocity, let's say, is 20 meters per second, and the initial velocity is, let's say, 10 meters per second, it means that the velocity change of this body, delta v, will be given by 20 minus 10, which is 10 meters per second. Now, if this change in velocity takes place in 2 seconds, that is, the speed of velocity of the body changes from 10 to 20 in just 2 seconds. It therefore means that the acceleration of the body will be 10, which is the velocity change, over 2. That gives you 5 meters per second squared. So it means that when the change in velocity is positive, when the final is greater than the initial velocity, it means the body accelerates. The speed has increased in 2 seconds, and the rate of increase of the speed is 5 meters per second squared. So that when you are told to explain what is meant by the acceleration of a body is 5 meters per second squared, meaning that if the body maintains this value for some 5-10 seconds, it means that every second the speed of the body increases. That is, the meaning of acceleration of 5 meters per second squared means that the velocity of the body increases by 5 meters per second every single second, as long as this 5 is kept constant, as long as that value is the same. That's what it means. That's what it implies. The velocity of a body 5 meters per second, that is acceleration of a body 5 meters per second squared, meaning that the velocity increases by 5 meters per second every single second. Okay. Now, number 3, delta V is negative. That is, the change in velocity is negative. To have a negative value, where we have V, delta V equals V minus U. For this to be negative, it means this initial velocity, let's say 20 meters per second, must be greater than the final velocity, let's say 10 meters per second. This is a case where the speed of the body is reducing. It's like the body is slowing down. The brakes have been applied, and that is reducing. Maybe the driver sighting some traffic in front of him will decide to, engage the brakes, and then the speed reduces from 20 to 10. It means that the difference will be negative -10. And since the difference in speed is negative, it means that the acceleration of the body is -10 if the time taken for this speed to change from 20 to 10 is 2 seconds. It means that the body's acceleration is -5 meters per second squared. And when we calculate acceleration in this case, and the result is negative, that implies deceleration, because deceleration is equal to negative acceleration. Deceleration simply means negative acceleration, meaning that an acceleration of -5 meters per second squared is the same thing as a deceleration of 5 meters per second squared. When we are stating deceleration, we do not include a negative sign, because negative acceleration is altogether representing deceleration or retardation, as the case may be. Just like we have for speed and velocity, we have different types of speed, different types of velocity. We have that for acceleration. We have the uniform acceleration, we have the non-uniform acceleration, we have the average acceleration, and so on and so forth. Now, for uniform acceleration, how do we define that? And that word for uniform is constant. It means that the velocity of the body increases at an equal rate, equal increase in velocity of a body at equal time interval. That means the acceleration is constant. Let me give you a picture from this table, meaning that the velocity increases at a constant rate for equal time interval. So let's say this table represents the velocity of a body against time, 0, 0. After 1 second, the velocity of the body is 5 meters per second. After 2 seconds, it is 10. After 3 seconds, it is 15. That's the velocity. After 4 seconds, velocity has increased to 20. So in this case, from this table of velocity against time, we can see that for every time interval 1 second, for each 1 second time interval, the velocity has increased by 5. From 0 to 5, that's by 5. 5 to 10, that's by 5. 10 to 20, that's by 5. So in this case, the body's acceleration is constant. And this can, if you are to draw the velocity time graph of this table, it will give you a linear graph, a straight line graph that is inclined at an angle theta to the time axis. So this is what you have there. And the graph like this gives you the graph of constant acceleration. So the next video we'll talk about that more. Then we have non-uniform acceleration. In this case, the acceleration is not steady. The acceleration changes with time because the velocity does not increase at a uniform rate. So when the velocity does not increase at a uniform rate, you see the velocity, the acceleration of the body is non-uniform. Okay, so and finally, let's take a question here. Suppose the body speed increases. The speed of a body or speed increases from, let's say, 36 km per hour to 72 km per hour in, let's say, 10 seconds. We want to calculate the body's acceleration, find the body's acceleration in this case. So how do we solve this? Quickly, we have to change 36 km per hour to meter per second. That will give us 10 meters per second. And we'll convert 72 km per hour to meter per second. That will give us 20 meters per second. Then the acceleration is 20 minus 10 divided by 10, which gives us 1 second. Of course, you'll be able to convert 36 km per hour. Multiply this by 1000. 36 times 1000 divided by 60 times 60. This is how we convert kilometer per hour to meter per second. That will give you 10 meters per second. So next video we'll solve more question on this. Thank you.